Hi friends, welcome back to our YouTube channel. In this video we will see 100 questions from strength of materials or mechanics of materials, which is also called. So this will probably will give you at least 4 marks. 4 marks you can expect from strength of materials. Let us see a very important questions. Practice these questions. I think you may get 4 marks. When a shaft is subject to a twisting movement, every cross section of the shaft will be under shear stress. Twisting is responsible for shear. The maximum shear stress developed in a beam of circular section is 4th by 3 times the average shear stress. The maximum shear stress developed in a beam of rectangular section is 1.5 times the average shear stress. When a load on the free end of the cantilever beam is increased, failure will occur at the fixed end because the bending moment is maximum. A beam is loaded as a cantilever. If the load at the end is increased, the failure will occur at a beam is cantilever. Okay, so definitely at the support, I think friends, anyhow we'll see the answer anywhere. Okay, so yes, I think anywhere, right. We will discuss this later, friends. Strain energy. What is the strain energy? Energy stored in a body when strained up to within the elastic limits. Within the elastic limits. Within the elastic limit. Strain energy. Let us see the answer. Yes. At the neutral axis of the beam, the layers are subjected to minimum bending stress. Or probably they do not undergo any strain, right? Actually it should be zero bending stress, friends. So there is no strain. Because there is no stress, there is no strain. So second is also wrong. There is no question of minimum. Zero. Because the bending stress is zero, strain will also be zero. Stress is proportional to strain within the elastic limit. And we are assuming that the beam is loaded below the elastic limit. For a given stress, the ratio of the moment of resistance of a beam of square cross section when placed with its two sides alternated to the moment of resistance with its diagonal E. This is friends
सुन मेरी लाली पाप कमरिया हिला के जरा नच दे सुन मेरी लाली पाप कमरिया हिला के जरा नच दे
sigma 2 is what is it? So the earlier one, sigma 1 is 1200, sigma 2 is equal to 600, tau s is equal to 400. If you substitute this angle normal stress, you are going to get as 1400 megapascal. A body subject to a test of 1200 megapascals and a test of 600 megapascal right angles is subject to shear stress of the minimum. So here we have to take the minus 1. So I think the formula is this one. Just check it. Sigma 1 plus sigma 2 by 2 plus or minus 2. Sigma 1 minus sigma 2 by 2 plus tau square under 2. Okay. So substitute this. There are questions, friends. I wrote the wrong formula. This is the correct formula. Sigma 1, sigma 2 are given. 1200, 600. And the tau is given as the 400. Substitute this. You take press, you are going to get the maximum normal stress. You take minus, you are going to get the minimum normal stress. So by substituting this, you are going to get 49 questions, friends. This is you are going to get 400 megapascals. 400 megapascals.
तो सुन मेरी लाली पाप कमरिया हिला के जरा नच दे
A body subject to a direct tension stress of 300 megapascals in one plane accompanied by a simple shear stress of 200 megapascals, the minimum normal stress. So make sigma 2 is equal to 0 in the earlier formula and substitute, because other direction normal stress is not given. So you are going to get minus 100 megapascals. That means compressive stress. minus is taken as the compressive stress and plus as the tensile stress. Okay, friends. A body subject to direct tensile stress of 300 megapascals in one plane accompanied by a simple shear stress of the maximum normal stress. Okay, so sigma 1 by 2 plus under root of sigma 1 by 2 whole square plus tau square. That is the formula. Okay, if you are making sigma 2 as a 0, this will be maximum normal stress under root of sigma 1 by 2 whole square plus tau square. Tau is called shear stress. If you substitute, you are going to get the answer as 400 megapascals. The tensile stress is performed on a round bar. After fracture, it has been found that the diameter remains approximately same at fracture. The method under test. This is a good question, friends. This is cast iron. This is cast iron. So there is no strain at all. There is no reduction of the cross section for the brittle materials. But for ductile materials, at fracture the cross section is going to reduce. Okay, area of cross section at the fracture is going to reduce. For brittle materials, there is no deformation. So they are going to fail without much deformation. So cross section will not change. That means it will be round. Diameter approximately same. But for ductile materials, the diameter is going to decrease under the tensile test. In calculating the strength of a riveted joint in tearing, shearing and crushing. So this is a good question, friends. Which diameter is to be taken? Actual diameter of the hole drilled for the rivet is used. Not the diameter of the rivet, nor mean diameter of the hole drilled, or not the smaller of the rivet diameter and hole diameter. This is a good question, friends. Please remember such question. A spring used to absorb shocks and vibrations is once again a good question, friends. This is leaf spring. Leaf spring. Okay. So that's why they are used in automobiles, your cars, your autos, your four-wheelers, lorries, etc. Okay. If you see behind, okay, from the side view, you are going to see a spring like this, right? This is your leaf spring. Right. So here, actually it should be like this, but the load will be coming from the downwards. Okay, friends. The shock will be coming from the downwards. Okay. That is called leaf spring. If TH is the torque resisting capacity of a hollow shaft and TS is that of the solid shaft, the same material and length and weight, then so definitely T hollow is more than T solid. So hollow shafts carry more torque compared to solid shafts for the same material length and weight. Hence they are used in naval applications and aircraft applications. Not only this, weight reduction is also an important factor. If kh is the torque resisting capacity of a hollow shaft and kc is that of the solid shaft, the same material length and right, it is the torque resisting capacity. So kh is once again greater than ks. Remember always, hollow shafts are more preferred because they are more strong and more torque resisting capacity for the same material length and weight. The bending moment at the free end of cantilever beam is, what is this? 0. Why? This is your cantilever, friends, right? So bending moment of this fixed end will be maximum. This is your free end. So it will be 0 because actually load is passing through this point, right? AB. So if there is some distance, then bending moment will be this load into this particular distance x. But because this x is 0 at this free end, bending moment is 0 at the free end. It will be maximum at the fixed end, but it will be equal to W into L. Load into perpendicular distance. A body subject to tensile stress of 200 megapascal, one plane and another tensile stress of 600 megapascal at right angles to the former. It is subject to shear stress of 400 megapascal on the same planes. The maximum shear stress will be, substitute in the formula, friends. You are going to get 500 megapascals. What is the formula? It is equal to under root of sigma 1 plus sigma 2 by 2 whole square plus tau square. Sigma 1 plus sigma 2 by 2 whole square plus tau square. All under root only. That is the maximum shear stress. A body subject to the direct tensile stress of 300 megapascals in one plane, accompanied by a simple shear of 200 megapascals. The maximum shear stress will be equal to. So it simply make sigma 2 is equal to 0. That means sigma 1 by 2 whole square plus tau square under root. Sigma is equal to 300, tau is equal to 200. That's the maximum shear stress. So you are going to get the answer as 250 megapascal. Right. Principal planes are planes having no shear stress. No shear stress. No shear stress. Remember this, friends. Principal planes are the planes having no shear stress, not the minimum, not the maximum, none of the ways ruled out. A rectangular beam of A has length L, width B and depth D. Another beam B has same length and depth but width is double that of A. The elastic strength of beam will be as compared to. So this will be B double. Okay, so right. So here BD square by 6, that is going to be very, very important, friends. That's the section modulus. Okay. So you have to calculate the bending stress. M, let us say that is same by Z. So he is making width is doubled. So what will happen? We will check it later, friends. Right. A simplest order beam A of length L, breadth B, depth D carries central point load. Another beam B has the same length and depth but the breadth is doubled. The deflection of beam will be as compared to B 1/2. So here the question is simply separate beam. Okay, so what is the formula for deflection? WL cube by 48 EI. Okay, WL cube by 48 EI. WL cube by 48 EI is the central deflection. So by taking all those EI you have to substitute. Okay, so now he is saying that breadth is doubled. Okay, B is doubled, depth D, breadth B. So by substituting I is equal to B D cube by 12 and considering B as doubled or not doubled, you are going to get the answer as what is the answer? 1/2. For the beam shown in figure, the shear force at A is equal to what the shear force? It will be B WL by 3. Two closely coiled springs having A and B are equal in all respects, but the number of turns of spring A is double that of the spring. The stiffness of the spring A will be dash that of the spring B. What is the deflection? W deflection of the spring 64 WR cube N by G D to power of 4. Right? G is the shear modulus, delta is the deflection, W is the load, R is the coil radius. So now he is number of turns. Okay, so number of turns, it is proportional to, delta is proportional to the number of turns. So what is the correct answer? It will be D 1/2. So because B is having number of turns of A is double that of the B. That of the B he is asking. Okay, just check it, friends. But the formula is that only. The shear force at the center of a simply supported beam with gradually varying load from 0 at both ends to W per meter the center is shear force A 0. So this will be your So let's see the question. So gradually varying load. Okay, so the situation is like this, okay, friends. Gradually varying load, right? So it is symmetrical from both sides. WL by, so this is WL by 2. Okay, this is your L. Okay, alright. So total load will be equal to half into W into L. WL by 4, WL by 4, and so it will be something like this. Okay, so your shear force diagram will be something like this. Shear force diagram will be something like this. It will be 0 at the center. The bending moment of a cantilever beam of length L and carrying gradually varying load from 0 at the free end per unit length to the at the fixed end, W at the fixed end. So he is giving the question like
कहती हलू हमरा दिल के बात अब डांस करब हम तोहरे साथ तो सुन मेरी सुन मेरी लाली पाप कमरिया हिला के जरा नच दे सुन मेरी लाली पाप कमरिया हिला के जरा नच दे
carrying a gradually varying load from 0 at the free end and W per unit length at the fixed end. Dash at the fixed end.
बेबी चीज बाड़ू मस्त मस्त कर देबू सबके पस्त पस्त तोहरा बनैले रच रच बस ट्रेनिंग तनिका ठीक लहो माहौल में आग लगा देबू बस ठुमका लगावे के सीख लहो
At the fixed end.
बहुत आस लगा के आपके पास हूँ आई जी मैं लड़की दीवानी आपकी फैन पागल तेजी अब जब आ गईलू तू भेटा गईलू
The bending moment of a cantilever beam of length L and carrying a function of W per unit length dash at the fixed end.
तो सुन मेरी लाल
Which of the following statement is wrong? The bulk modulus is the ratio of linear stress to linear strain. This is the wrong one. Okay, what is the bulk modulus? By the way, normal stress to the volumetric strain. K is equal to normal stress to the K is equal to, let us see, K is equal to sigma n by EV, volumetric strain. Others are correct. Others are correct. These three are correct. Deformation per unit length in the direction of the force. The deformation of the bar per unit length in the direction of the force is called linear strain. The Poisson's ratio is the ratio of lateral strain to linear strain. The ratio of change in volume to original volume is called the volumetric strain. But this is the wrong one, fourth one. Which of the following statement is wrong? Let us see the answer first. C is the wrong answer. What is this? At the neutral axis of the beam, the bending stress is maximum. It is 0. It is 0 at the 0. Sigma B at the neutral axis is equal to 0. There will be no strain at all. Because there is no bending stress, there will be no strain. That's why it is called neutral axis. Okay, above the neutral axis, the fibers are subjected to tensile stress, and below the neutral axis, they are subjected to tensile stress, or vice versa, compressive and tensile. Above and below, or below and above, according to the load direction. That you have to remember. So all these are correct. The assumption is right. This is also right. This is also right. Inversely proportional to section modulus. So it is something like this. Sigma B is equal to M by Z. Sigma B is equal to M by Z. M by Z. Z is equal to I by Y. M by Y. So, okay. it is proportional to y and it is inversely proportional to I. Okay, substituting for z, I have substituted z is equal to I by y. So that is a wrong answer. In Mohr circle, the center of circle from wax is taken as, this is a good question friends, B sigma x plus sigma y by 2. A beam of uniform strength may be obtained by, so any of the things will ensure beam of uniform strength, keeping the width uniform and varying depth, keeping the depth uniform and varying the width, varying width and depth both. Either change B or D, or B and D. You can keep the, you can get a beam of uniform strength by combination or single at a time, width, depth and both. Two shafts A and B transmit same power. The speed of the shaft is A is 250, that of shaft is 300 rpm. Now the question is, the shaft A has the greater diameter. The shaft A has the greater diameter. Shaft A has the greater diameter. Power. What is power? 2 pi nt by 60,000. Right. Now what he is asking, so same power, the speed of shaft is 250 and that of the shaft is okay. So he is asking, the shaft has a great diameter, so whichever is having less, will be having more diameter. The maximum bending moment for the beam is shown below. This is a good question friends, it is often asked in the examinations. Remember this value and this figure also. W square by 9 root 3. Remember this question, this is a very important question friends. So he is asking maximum bending moment for the beam. So it is a cantilever beam with uniformly distributed load, 0 at the right support, sorry it's not cantilever beam friends, simple support beam, with right support 0, left support W per unit length. So for this, maximum bending moment is W square by 9 root. This question is often more asked in examination. The neutral axis of the cross section of the beam is that axis at which bending stress is 0. Bending stress is always 0 at the neutral axis. It is neither 0 nor maximum nor infinity. The neutral axis of the cross section of the beam is that axis at which bending stress is 0. Bakalım o zaman seni kim kurtaracak? Seni gidi vurdum duymaz, seni gidi yaramaz. Canın isterse arsın, istemezse yaramaz. So both questions are same. The torque transmitted by a shaft, solid shaft of diameter d, where tau is maximum conscious, is pi by 16 d cube into tau. This is the correct answer. This is the correct answer. So, pi by 16 d cube, right? This is pi by 16 d cube is called ZP, polar modulus. Okay, tau is the equal to torque. Polar modulus is equal to pi by 16 d cube for solid circular shaft of diameter capital D. Torque transmitted by hollow shaft of outer diameter d1 and d2, inner diameter d2, where tau is the maximum stress is given by pi by 16. This one, okay, this is your B. Pi by 16 will be same, but here d1 to the power of 4 minus d2 to the power of 4 by d1 do. Okay, so outer diameter. D2 is the inner diameter. That's what he has given, right friends? The total strain energy stored in a body is termed as, this is a good question friends. It is resilience. It is just resilience. Total strain energy is called as resilience. Proof resilience is the strain energy stored up to elastic point. Modulus of resilience is the strain energy per unit volume. Okay, toughness is something different, friends. Toughness is something different. More cycle is used to determine the stresses on an oblique section of a body subjected to all of them. Okay, it is used. More cycle is a graphical representation of finding out the stresses: maximum stress, minimum normal stress, maximum normal stress, and also maximum shear stress and principal planes also, friends. So anything can be found out from the graphical representation. More circular direct tensile stress in one plane compared with shear stress, direct tensile stress in two mutual perpendicular directions, direct tensile stress in mutual perpendicular directions, and accompanied simple shear stress. Okay, three cases will be there. So like this. Okay, this is the first case. This is the second case. This is the third case. So all of them. A column of length L with both ends fixed may be considered as equivalent to a column of length dash with both ends hinged. This is C, L by 2. L by 2. Pi square EI. So what is the Euler's critical load? Pi square EI by L square, LE square. LE is the equivalent length. Okay. So you get 4 here L square. So if you substitute L by 2 whole square, so LE is equal to L by 2 for both ends fixed. In a tensile test near elastic limit zone, what is the correct answer? Tensile strain increases more quickly. This is a good question, friends. In case of an under reinforced beam, the depth of actual neutral axis is that of the critical neutral axis. It's a good question, friends. Once again, it may be useful for civil students. Less than. When a body is subject to a change of temperature and its deformation is prevented, the stress induced in the bar is, what is this, friend? This is thermal stress. Because temperature is involved, it is going to be thermal stress. Stress can be included in a member, mechanical member, by the way of loading or even by heating it also and preventing its expansion. So the scene is like this, okay, friends? The scene is something like this. The scene is something like this. This is bar. So I am heating this, okay? So actually, if so it will try to come to this position, but this is prevented, okay? So definitely it will try to push, but anyhow it will be subjected to compressive stress, right, friends? Okay. So now this stress induced because of this particular scene is called thermal stress. A bar of length L meters extends by L mm under tensile force P. The strain produced in the bar is D 0.001 L by L. So because actually what is this? Strain is equal to delta L by L. Delta L is equal to 1 L mm. Okay. And L is equal to L meters is given. L mm, right? L meters means 1000 L. So this is equal to L. So L by L 1000. 1 meter is equal to 1000 mm. You know that, friends? Substituting that, we can get the strain produced is equal to 0.001. That means L by 1000 L, capital L. The weakest section of the diamond riveting is the section which passes. So this is a good question, friends. Once again, one rivet hole of the end row. This is from the rivets. The questions are from rivets. Strain is equal to delta L by L. Change in length by original length. In leaf springs, the maximum bending stress developed in the plates, W is equal to load acting on the spring, yield span of the spring, a number of plates, B width of plates and T thickness of the plates. So this is equal to 3 by 2. This is a good question, friends. Remember this formula. 3 by 2 WL by N BT square. N is the number of leaves, total number of leaves, including master leaf and small leaves. Graduated, they are also called graduated leaves. This is your leaf spring, okay, friends. So this is graduated leaf, LG, and these are, sorry, these are LG, graduated leaves, and this is main leaf, principal leaf. Formula based on IS codes is based on, this is a good question, friends. Secant formula, there is something called secant formula, okay, not Euler's formula, not Rankine formula, state line formula, right? Secant formula. Rankine formula is applicable for both types of columns, short and long column. Euler's formula is applicable for long columns, and state line formula we are not going to use. We are going to use secant formula for IS code, okay, members. Formula based on IS codes is based on secant formula. The elasticity of various materials is controlled by its, what is this? Stressed elastic limit, that's called yield point. Yield point is itself is a, yield point is a stress set, okay, yielding. So to confuse, this is given, friends, okay. Stress at elastic limit is called yield point, okay. So one more extra word is given, the stress. So you have to be very, very careful. Ultimate tensile stress is this one, right? So if you see the stress strain diagram, it is something like this, friends, right? This is ultimate tensile stress, this is your yield point, this is your breaking point, correct? This is your stress, this is your strain, for example, right? So the stress at elastic limit, this is yield point, it is called yield point. So your elasticity of various materials is governed by stress at elastic limit. When two main plates are kept in alignment, butting each other and riveted with the cover plate on both sides of the main plate with two rows of rivets in each main plate, the joint is known as, this is a good question, friends, double riveted joint. Double riveted joint. Double riveted, double cover butt joint. Double riveted, double cover butt joint. So this is your plate, this is your plate. There's a plate over there, there's a plate over there. This is, here butting is taking place, okay. And now here riveting is done. The materials having same elastic properties in all directions is called, this is a good question, friends, isotropic material. Isotropic material. It will have uniform properties in all directions. There are infinite number of directions, but they will be having all the material properties like E, G, Young's modulus, modulus of velocity, modulus of rigidity, bulk modulus, and Poisson's ratio, equal in all directions. Such type of materials are called isotropic materials. Isotropic. Neither uniform nor ideal nor practical. No. Isotropic. The materials which exhibit the same elastic properties in all directions are called, once again, friends, isotropic only. So question is repeated, no problem. A material capable of absorbing large amount of energy before fracture is known as, this is toughness, resilience, shock proof, ductility, no. Toughness. So toughness is, it is something, okay. So total energy stored up to fracture. This is your stress, this is your strain, this is your fracture, okay, friends. This is ultimate tensile strength, UTS, this is yield point, for example. Below that you are got proportionality limit, like that, okay. So this is your stress strain diagram. So up to fracture you have to consider that energy stored up to that is known as toughness. Resilience is something below and up to yield point. Okay, ductility is the property of getting elongated. Okay, the more the elongation under tensile load, the more the ductility. So you have to distinguish these properties very very carefully. Young's model is defined as the ratio of longitudinal stress to the longitudinal strain. Actually it should be normal stress, friends. Okay, normal stress to the longitudinal strain, EL. But sometimes some people call it as longitudinal stress. Volumetric stress to volumetric strain, shear stress to shear strain, this is your G. This is modulus of rigidity. This is your Young's modulus. Lateral stress to linear strain, no. Okay, right. Volumetric strain to volumetric strain, so something like that. This is your bulk modulus. Okay, this is your bulk modulus, K. So it is used, the word longitudinal is used because actually, friends, so your body is like this, you are trying to apply the role along the longitudinal axis. That's why it is called longitudinal stress. But it induces stress on the normal section. So it can be called as normal stress, longitudinal stress or normal stress. Modulus of rigidity is defined as what is this? Shear stress to shear strain. Shear stress to shear strain. Tau by ES. This is called your G, or it is also given by some phi. Shear strain is given as the phi. Young's modulus is defined as the ratio of, once again repeat reference, linear stress to linear strain. Longitudinal stress, linear stress, normal stress, all are same. Poisson ratio is defined as it is a lateral stress and longitudinal stress. Wrong, friend, this is okay. So actually it should be lateral strain by E longitudinal strain, that is your mu, Poisson's ratio. Stress in strain in the normal direction by strain in the longitudinal direction. For example, I have got a bar like this, right? I am loading like this, right? Your diameter, this is your diameter. Let us say this is the length, okay? So diameter will decrease and length will increase. So delta D by D, lateral strain, by delta L by L, longitudinal strain. This is known as your Poisson's ratio. Poisson's ratio for steel is 0.3, friends, around 0.3, 0.3 to 0.33, 0.3 to 0.33, right? Some books give, it is given as 0.25 to 0.3 also, friends. Not a problem. Strain is the ratio, is defined as the ratio of change in length to the original length. Not the cross section area, nor the volume, nor any of the above. Factor of safety, this is a good question, friends. Factor of safety is defined as ultimate stress to working stress for brittle materials. In fact, okay, it is given as the for brittle material, okay, but ductile materials it is yield stress to the working stress. For ductile, ultimate tensile stress to working stress for the brittle materials. So it's given for brittle materials. A fletched beam is used to, this is a good question, friends. Fletched beam is to equalize the strength in tension and compression. Not this, not this, not this. That means not for change the shape of the beam, not for affecting the saving in material, not for increasing the cross section of the beam. A rectangular beam of length L supported at its two ends carries the central, the maximum deflection occurs at the center. At the center only. Okay, so this situation is like this, something like this. Okay, this is your, so deflection, this is your this elastic curve, this curve, original beam is the elastic beam after the beam shape after bending. So the deflection will be maximum at the center. At supports it will be 0. Deflection at supports will be 0 and it will be maximum at the center, and that value will be equal to WL by 48 EI. E is the Young's modulus, I is the moment of inertia of the cross section of the beam, W is the load, central load, L is the span of the beam or length of the beam. The ductility of the material dash with the increasing percent reduction area of a specimen under tensile test. So it is going to increase, ductility is going to increase with the percentage reduction, increase the percentage reduction in the area. The more the area of reduction, the more the increase in length. So definitely it is going to increase. Yes or no? Alright. For example, so this has taken shape like this, right? This can take the shape like this also, right, friends? Right? So here the diameter is decreasing. That means area of cross section still decreasing. So this will be more ductile compared to this. Yes. The ductility of material dash with a decrease in percentage elongation or decreases. It should be decreasing, right? Decrease with the decrease, increase with the increase of the percentage elongation. So in fact, percentage elongation is a indication of the ductility of the material. What is percentage of elongation? Area of the cross section. Okay. What you call before A1 minus A2 by A1 into 100 percentage elongation. Okay, A2 will be less, A1 will be more, and initial area of cross section minus final area of cross section by initial area of cross section into 100. That's called percentage reduction. Percentage reduction. It is an indication of the ductility of the material. The total elongation produced in a bar of uniform section hanging vertically downwards due to its own weight is equal to that provided by the weight. Half the weight a bar applied at lower end. If the modulus of velocity for a given material is twice its modulus of rigidity, the bulk modulus is equal to, this is your C. So these are the relations between E Young's modulus, K bulk modulus, mu Poisson's ratio, and G is the modulus of rigidity, right? Solving this, you can find out, you can easily see that bulk modulus is equal to 2C by 3. Here he has taken C as the bulk modulus is equal to modulus of rigidity. So he has given E is equal to, friends, let us check it once again. So E is equal to bulk modulus of E is equal to twice the modulus of rigidity. So E is equal to 2G he has given. So you can use these expressions and arrive at the answer, friends. Please check it, no problem. A steel bar of 5 mm is heated from 25 to 45 degrees and it is free to expand. The bar will induce no stress. Why? There is no prevention of the expansion or elongation. So there is no stress. Had it been prevented, the temperature stress or thermal stress would have been introduced or induced. For a beam I shown figure below, the deflection at the C with all those things, right? So how much it is? Let us see, friends. I think it's something related with this second, I think. Yes. W A square B square by 3EIL. If you substitute, so A is equal to B, right? A is equal to B is equal to L by 2. You will get WL cube by 48A. So it is going to be same as simply supported beam with the central load. Okay, but here's A not equal to B. So then W A square B square by 3EIL. The assumption generally made in the theory of simple bending. This is a good question, friends. All of these are the assumptions of the theory of simple bending. Homogeneous material homogeneous, stressed within the elastic limit. Plane sections remain after bending and before bending plane. The thermal stress in a bar is directly proportional to the change in temperature. Directly, thermal stress is directly proportional to the change in temperature. The more the change in temperature, the more the thermal stress. So sigma thermal is equal to okay. So your stress is equal to strain, thermal strain is equal to how much? Change in length by original length into delta T. Okay, friends. Right. Thermal stress is equal to, it is directly proportional to, right. So if you substitute thermal stress is equal to load by, so your load by area, that means stress. So it is something related with your what you call, so you have to use, definitely it is proportional to the temperature, friends. Just check it, no problem. The maximum shear stress in the given figure is equal to dash of the radius of the, always maximum shear stress will be equal to radius of the your, let us see the answer, it should be A. The maximum shear stress will always be equal to the radius of the circle, not the diameter, not the circumference. Remember this is a good question. Percentage reduction area performing tensile test on cast iron may be of the order of percentage reduction. How much? This is a good question, friends. 20% is very least. Sometimes zero also, friends. Actually, percentage reduction will be zero for brittle materials normally, but some cases it is 20%. It is least among all the values because it is a brittle material. For ductile materials, it will be highest. The percentage reduction area for a cast iron specimen during tensile test will be of the order of, once again is given as same, negligible. So earlier I think it was it should be friends, I think it should be not cast iron, it may be, I think it should be steel, mild steel. Check it. So this is correct actually. Zero, negligible, because it's a brittle material. So there will be no elongation, no deformation. Without any deformation, without any sign of deformation, they are going to fail. Brittle materials under the tensile load. Negligible is the correct answer. Percentage reduction area per tensile test on cast iron may be of third round. So once again, zero, friends. This is zero. Just remember this. Negligible, zero, both are same. A thick cylindrical shell having R odd Ri as outer internal radii is subjected to internal pressure P. The maximum tangential stress at the inner surface. This is a good question, friends. Remember this. It is P into R1 square plus Ra square plus Ro square by Ro square minus Ri square. So this is about the thick cylinders. In thick cylindrical shell subjected to an internal pressure of P, the maximum radial stress at the inner surface of the shell is, it is minus P, compressive. Outer it will be 0. A thick cylindrical shell having R naught Ri as the outer inner diameter radii subject inner pressure of P, the maximum tangential stress. This is a good question, friends. I think it should be A. A column of length L with both ends fixed may be considered as equivalent to a column of length dash with one end fixed and other end free. This is B, L by 4. A beam which is fixed at one end and free at the other end is called cantilever beam. Neither simply supported beam, nor overhanging beam, nor fixed beam, nor simply supported beam. It is called as cantilever beam. The strain energy stored in a circular shaft subjected to shear stress tau is a good question, friends. Tau square by 2g into volume of the shaft. 4g you will get when it is subjected to torsional shear stress, but for tangential shear stress it should be tau square by 2g. Had it been like this, for example torque, it should be tau square by 4g. But here the situation is like this, friends. Okay, tau tau. It's called tangential shear stress. There are two types of shear stresses: tangential and torsional. Torsional due to rotation, tangential due to the applied force is tangential to the direction. The strain energy stored circular shaft in torque subjected to shear stress tau. Just now I was referring to, friends, tau square by 4g. At the neutral axis of the beam, the shear stress is maximum. Okay, friends. But the same is 0. The bending stress is 0 at the neutral axis, but shear stress is maximum at the neutral axis.
Lot of channels that they keep subscribing to.
So it is like this, friends.
That doesn't really help in the decision.
So bending stress, this will be like this. This is neutral axis, okay? Bending stress, this is bending stress. But shear stress, it will be like this. It will be maximum. Shear stress, tau. It should be maximum at the neutral axis, right? But bending stress is 0 at the neutral axis. Principal plane is plane which shear stress is 0.
So Greek mythology, there's a king named Peleus, and he married this beautiful
Neither minimum nor maximum nor none of the above.
And they are blessed with a child.
The maximum deflection of a fixed beam of length L carrying load W uniformly distributed for the whole length is
But with
192.
So it is the beauty
For simply supported beam, it is 48 EI,
protect her son,
but for
takes him to a magical river,
this will be
immerses him.
WL by 48 EI,
That river has magical power.
WL by 192 EI.
And because
That
Theseus
means
was holding
into
the child
1/4.
from the heel,
So
when she dipped
that's
it,
why
the
your
child
fixed
into
beams are used,
water,
friends,
the heel
to
did not
reduce the
touch the
central deflection.
water.
Okay,
So Achilles,
it will be 1/4
the weak
compared to the
in his body, because
simply supported beam.
after the
In case of a
Trojan
fixed
War,
beam,
where
two beams, one of circular section, other of square cross section, have equal area of
Paris
cross
of
section.
Troy shot
When these beams are subjected to bending, now which is economical?
led to the death of
Square section beam is economical. This is a good question, friends.
This is the vulnerable point of any project or any person. So, for investors,
In a belt drive, the pulley diameter is doubled, the belt tension pulley width remaining same. The change required in key will be.
that information or
This is a good question, friends. Increase in width,
the investor in the decision making process.
not length
So
nor
noise disturbs
depth,
an investor
but
rather
width is
than
to
help
be
an investor.
increased.
And that leads to bad decision making or loss investment. All good investment plans are
In a tensile test, when the material stress is beyond the action, the tensile strain as compared to the stress,
careful about. This
it
your
is
kryptonite
increases
for
more
investor.
quickly, right? So it is already in the deformation zone. Definitely, it will increase more quickly, more rapidly. Now it has already crossed the yield point. So when you load more, definitely it is going to be increasing more quickly. So that's what he's saying. Beyond the elastic limit, the tensile strain as compared to the stress.
Or magnified
Compared to stress, the strain increases more quickly and rapidly. For a beam shown in the maximum deflection light, this is a good question, friends. It is asked more number of times in your examination. C L square A square
combined actually
by 3 root from B.
levels of noise in the
From B.
And a long-term investment.
From B you have to be
Segregate
considering.
between the signal and the noise. To get an
Maximum
information
deflection,
error, you get
this
the
will be
right
like this,
signal
okay, at that
within the
location,
data.
along the
It
beam.
should not be vulnerable to noise. One of
The ratio of elongation of prismatic bar due to its own weight compared to another similar bar having additional weight W will be, so much it will be B, 1:3. So 1:1 plus twice, 1:3. Because actually friends here this is like this, okay. Now additional weight, this is weight, right? Which of the following is statement is correct? Which is correct? All of them are the correct answers. That means energy stored in body when stored within elastic limit is no stay energy. The maximum energy can be stored in body termed as proof resilience maximum. Okay. Proof resilience per unit volume is known as the modulus of resilience. All of them are the correct definitions of the terms described. Which of the following statement is correct? A uniformly distributed load spreads more uniformly over the whole length of the beam. Continuous beam has more than two supports. This is wrong. Okay, friends. Now, the bending moment is maximum where shear force is maximum. No, it is 0. Shear force is 0. The maximum bending moment is simply supported beam of length L. Central point load is no. It is something different. So, that is the correct answer. Which of the following statement is correct? Once again, a good question, friends. Rivets are generally specified by its shank diameter. Shank diameter. It's a good question. So, this is correct. Center is for 2 consider beam margin. Let us see what is this. Correct. Okay. So, right. Tearing plates can be avoided by taking the pitch of rivets equal to 1 times the diameter of the roll rivet. So, this is only C is the correct answer. Which of the following statement is correct? Stress is directly proportional to strain within the elastic limit. That is the correct one. Stress is pressure per unit area. No. Load per unit area. Right. Strain is expressed in mm. No. 0. It has no units. This is wrong answer. Hooke's law holds up to breaking point. No. Up to only elastic limit only. The bending momented section tends to bend or deflect the beam and the interstresses resist the bending. The resistance offered by the interstresses to the bending is called bending stress. Neither the compressive nor shear nor elastic modulus. So clearly he is saying that bending moment is responsible for bending stress. The stress developed in the material without any permanent set is called elastic limit. If there is a permanent set or deformation, it is something, okay, plastic stress, okay, after the elastic point. So he is saying that without any permanent set, the permanent deformation, okay, that's called neither yield nor ultimate nor breaking. It's called elastic limit. Okay, friends, I think that is the correct answer. The maximum bending moment of simply supported beam of span L carrying a point load at the center of the beam is WL by 4. This is how. This is the. So this will be W by 2. This will be W by 2. This L and this is L by 2. This is L by 2. So this will be, let us say C. This is A, B. W by 2 to L by 2. WL by 4 is the maximum bending moment. And the bending moment diagram will be something like this. WL by 4 for simply supported beam having central load. In the below figure, dash represents the glass. This is a good question, friends. Curve C represent the glass. Okay, this is the steel and some other materials it is given, but C is that for glass. walls. According to Euler column theory, the creeping load for a column of length L with one end fixed and the other end hinged is. Okay, this is a good question, friends. So such type of questions are asked. Let us see the answer. Either it should be B or D. Let us see. Yes. So no. Actually, both end fixed, both end hinged, one end fixed and other end free, one end fixed and other end hinged. Okay. So when this is the case, 2 will be coming into the picture. Pi square 2 pi square EI by L square. So the 4 conditions, always remember, you are sure to get one question out of that. 4 conditions, friends. Okay. So in this video we have seen 100 questions, best questions, good questions from your basics of strength of materials, from which you can expect at least 4 marks, friend. If you do all these 100 bits correctly and check the answers, probably you will be able to what are the questions 2, 3 or 4 from the strength of materials without any problem. I hope you enjoyed the 100 questions, and if you like my channel, please subscribe and share among your groups and contacts. Let us meet in the next video with another section.